Over the past few months, I've noticed that some students in year 10, 11, and 12 make common mistakes with their chemical equations and it end up uh, getting wrong calculations and just ruins their whole experiment because of one tiny mistake. Unfortunately, this affects the exams and the quizzes as well. So if you don't know how to balance your chemical equation, all your other measurements are also wrong. But don't worry, I have a very simple trick and easy to learn that will help you get all your equations right. Right over here, I have a very simple combustion reactions. It involves methane reacting with oxygen, gives us carbon dioxide and H2O. We don't know what the coefficients are, and that's what we're gonna find out. If you count how many of each element we have on the reactants, it should equal to the products to have a balanced equation. So on the reactants, we have, sorry, let me get rid of this. Let me change the color. Okay. On the reactant side, we have 2 carbons, 8 hydrogens, and 2 oxygens. On the products, we have 1 carbon, 2 hydrogens, and 8 oxygen. Oops, my bad. Yeah, see, this is a very good example of checking your elements properly. Otherwise, you will make some simple mistakes and it will ruin your whole calculations. Okay, so 3 oxygens. Now, how do we balance this? Well, the trick is of balancing any equation is to leave the most frequent or the most common appearing element last. So if you see there's oxygen here, oxygen there. So leave that till the end. So do the most do the least frequent. So like carbon, hydrogen. Okay. So to balance this, we have to have the same elements on both sides. So we have 2 carbons over here. Reasonably, we need to multiply this by 2 to give us the same amount because we have 1 carbon. So 2, so multiply gives us 2 carbons. So write that down here. And 2, yeah. Okay, simple enough. Actually, I will stay with red. We have 8 hydrogens on the left hand side, but 2 over here. So reasonably multiply by 4 because to get 8, so 4 times 2 gives us 8. So take that 4 here. Now oxygen, since we did all of this, our oxygen value actually changes. So 2, 4 doesn't really stay as 3 because if you do 2 times 2 gives us 4 and 4 times 1 gives us 4. So if we have 4 here and 4 over here, the total amount is actually 8. It's not 3 anymore. It's actually 8. So if we have 8 on the right hand side and 2 on the left hand side, we must multiply the oxygen on the left hand side by 4 to give us the same number. So multiply by 4 and we have the same amount. Okay, now let's check our 2 times 1. Okay. Now let's check if our equation is balanced. We have 2 carbons over here, 2 carbons over here. Let me just rub this off. That's correct. Carbons are good. Okay. Now hydrogen. 8 hydrogen and 4 times 2, 8 hydrogen. Hydrogen is correct. Now oxygen. So we have 8 oxygens here. We have 4 over here and 4 over here. The oxygen is correct. There you go. You have a simple balanced equation. Now I'm going to write a new equation and I want you guys to still do it and then I'll continue the video and see how you go. Okay, now have a go with this and see how you do. Okay. Now remember, leave the oxygen over here, oxygen here. Of course, we have to do that at the end. So now let's try with carbon. 5 over here, 1 over here, multiply by 5. Let me change the color again. Okay. 5 here. Okay, millimeter. 5. Okay. Now let's do the hydrogens. We have 2 hydrogen over here, 12 of this, so multiply this by 6. So 6 hydrogen. Remember the oxygen also not value changes because we have multiplied by here and 6 over here. So 5 times 2 is 10, plus 6 times 1 is 6. So 16. Okay. Now since we have 16 oxygen, remember this value changes to 16. We have 16 over here and 2 over there. The value also changes, so multiply this by 8 to give us 16. Same amount of oxygen. So actually, let me write this and give a bit more space and change it to 8. Now check your equation. We have 5 carbons, carbon's correct. We have 12 hydrogens, 12 hydrogens, correct. We have 16 oxygens, 10 over here, and there 16, correct. And good luck. I hope you enjoyed this.